Okay, round two, because my son came out during the first video. April Bafford. This is for the DNA replication video. Hopefully he stays in bed this time around. So we are going off of this picture as far as DNA replication goes. So for this replication, we have the parental DNA and the daughter DNA. We have an origin of replication where the parent strand has unwound and the daughter strand has been built. So here the replication bubble formed and expanded or separated. The helicase broke the hydrogen bonds and separated, the DNA strands. And then the helicase was like a zipper that opened up at the fork and is continually opening up and separating, while the, did I say this right? Toipsomerasis is leading the process in front of the fork, making sure that as the helix is unwinding that it doesn't get knotted and create any sort of knot. So as that's happening, the parental DNA is going from let me rephrase this. So the first set of DNA helix has a 5 to 3 prime and a 5 prime to 3 prime happening. So on the first parent DNA, we have the daughter strand starting at 5 prime and going to 3 prime. So there's a DNA polymerasis. I'm saying these so terribly wrong, but 3. That is going from 5 prime to 3 prime because that's the only way it can go. It's using a primer and a template strand, and it is the leading strand. And so because it DNA polymerase 3 is attaching to the 3 prime side, it's happy and beautiful and is going right along. However, on the other strand, the daughter strand is going in a 3 prime to 5 prime, which the DNA polymer 3 does not like. So here is where we come into our oikizakis. Is that how you say that? It is the Okazaki fragment. There you go. So this is where Okazaki fragments start. So here we have the man, there's a lot of verbiage in here. So here we have the lagging strand. So because it's going from 3 prime to 5 prime, it has a lagging strand. So we have those Okazaki fragments. And what is happening is the RNA RNA primers coming in and creating the starting point for that to build off of. And there's fragments of it. And as soon as that one's done and it gets to the end or the fork, it detaches itself and goes back to the beginning towards the origin of replication and keeps creating those fragments. Those fragments are joined together by the DNA ligase. And directionality of the 5 prime and 3 prime ends. So there are, on each strand, new strand that's being built, the origin of replication, the top strand is the 3 prime to 5 prime, and then the daughter or the parental on the top strand is 3 prime to 5 prime, and then the daughter one is 5 prime to 3 prime. So the polymerase 3 is happy and can just move right along. And then on the second strand, the parent from origin replication is going 5 to 3, which means that the daughter is going 3 prime to 5 prime, which is where those Ozaki fragments come into play. And the DNA ligases come in and we build little sections at a time. And then, I forgot about the single-stranded building proteins. So as the strands are separating at the beginning, creating that bubble, the single-stranded binding proteins go into each helix to keep it from combining back down. and combining back together again with the original parent helixes. So hopefully that made sense.